Hello, my name is Filip Benna. I work at Codasip as a product manager. And today I will talk about how we at Codasip enable our customers to create truly differentiated designs and how does it align with something that I would call architecture licenses in RISC-V. At first, of course, I would like to talk a little bit about the company. So we really are the European RISC-V company. We do provide portfolio of RISC-V IP cores as well as an EDA tool. We are the founding member of RISC-V International. We have actually released the first commercial RISC-V core in 2015. Since then, we shipped over, or our customers shipped over 2 billion devices with our IP in them. We have the headquarters in Germany, so this is really our home event. And we have the entire R&D based in Europe. So the biggest R&D center is still in Czech Republic, which is basically a drive from here. We have design centers in France, we have 2 design centers in UK, we have just opened design center in Spain, so really a lot of people developing our products in Europe. Besides our development in Europe, we do have sales and FAs all around the world, so you can find our sales offices in US as well as in Asia, so Korea, Japan, China. I would like to mention that one of the business models that we can provide to our customers is a standard IP licensing. This is not really the twist of my presentation. The twist will come later, so wait for that. But this is really a standard model that I'm sure that many other vendors around here can provide. So what does it mean is that we have a portfolio of RISC-V cores, which range from very small embedded microcontrollers to application cores, which can be part of a multi-core cluster. And we can deliver them to our customers as RTL that they can configure. So that means that you can, using parameters, turn some of the features off, some of them on. You can choose different sizes of memories, etc. You probably know this model very well. We do deliver the standard deliverables that you can think of. So, compiler, simulator, debugger, all the things that people would consider a standard thing when they buy a IP core. This is a very common model for us as well, so we have customers using that. The cores are silicon proven then. The twist actually starts here. So what we believe we can do much better than any other RISC-V vendor here is that we can enable our customers to create differentiated designs, and we have the right products to do so. So it's not just the portfolio of the IP cores, but it's also a tool that we call Studio, which is an automated EDA tool set. And basically the rest of my presentation will be mostly about it, so I will explain in the upcoming slides. And when you combine these two, what you basically get is an architecture license for a RISC-V core. Why would anyone care, right? I already said that you can get an RTL from many vendors. Typically it comes with a bunch of parameters that you can change. So why would anyone care about some customization that I want to talk about here? Well, sometimes you want to make changes which go beyond what the parameters can provide, right? Let's say that you want to change the architecture of the processor, which typically means that you want to change the instruction set. Well, that's not possible with RTL parameters. The generic use case why you would do it is because you want to optimize the architecture of your processor for the very specific applications that you run on the processor. We have plenty of very specific use cases like this that go into blog posts and white papers. Actually, my colleague John was here yesterday talking about one of them. Unfortunately, I do not have a time machine to take it back there, but John is here until tomorrow, so if you want, you can stop at our booth and we can talk you through it. What I want to expand in this talk is, can you really change an architecture of a processor? Or maybe I should say, may you really change an architecture of a processor? Which brings me into the fun slide of my presentation, which is a language corner. So this is a subtle difference between the words may and can in English, which I try to describe as a joke here. Some people would call it a dad joke. Well, it goes by kids saying, can I have the last slice of pizza? And the parent can reply, well, I'm sure you can, but the question is whether you may. And this refers to the fact that there are things in the world which you have to be allowed to do, so you may do them. But the other thing is that even though you're allowed, it doesn't really mean that you're physically capable of doing them. So let's actually start with the easier thing. May you change the architecture of a processor? I have a good news for you, because you're on a RISC-V stand, you have very likely chosen your processor to be RISC-V, and in such case, you may. The reason for this is that RISC-V is an open standard. Many people used to confuse it with open source, so I do have this slide also for this reason, to basically explain the difference in the table which is on the slide. So if you choose to use a proprietary architecture with the intent to modify the architecture, you would have to think about two things. Do you have to pay so that you get the specification of the architecture that would allow you to modify it? Well, you would have to. And then if you want a specific implementation of that architecture, you will pay for that as well. That's licensed. If you decide to use RISC-V, the good thing about open standard is that no one will charge you for the specification of the architecture itself. Whether the implementation of the processor is free or not, that really depends. There are, of course, open source processors in the world. Some of them are RISC-V. And if you can use open source, then that's your option. But if you will choose a commercial RISC-V vendor like Codasip, of course, there is also a license fee for the implementation of the processor. So this question of may becomes quite difficult because sometimes it is really a question of money. If you pay for it, then you typically allow it. If you choose RISC-V, you don't have to worry about it. Eventually, any of these models will provide you with an RTL implementation of the processor. So I'm getting to the more difficult part, is whether you can modify architecture of a processor when you have the RTL implementation. Well, is RTL all you need? It's not, I believe. With RTL, I'm sure if you consider modifying architecture of a processor, I'm sure you have lots of design engineers who can take RTL of your base processor and modify it to change the architecture in the way you want. But that's typically not enough, because that would only give you the implementation which eventually will take you to silicon, and that's a lot. But there are many other things which many people take for granted, which will stop working once you touch the instruction set. That can be the compilation toolchain. If you now have compilation toolchain for the architecture that you start from, and you change it, the compilation toolchain will no longer work because it implements the former architecture. The same goes for simulator, debuggers. You will have to verify the implementation again. So I don't think it is just about the RTL. And actually, this is where Codasip comes in really handy, because we can solve it for you. We have a tool called Codership Studio, and the simplest way to describe it is that Codership Studio consumes a definition or implementation of a processor in a language called Codel. It will automatically generate the HDL implementation, so your Verilog, system Verilog. But from the same implementation, we can also generate compilation toolchain for you, simulator, debugger, verification environment. Many other deliverables will be automatically generated from one description of the processor. The description has to be able to comprehend for the instruction set as well as the microarchitecture. So this should give you the idea of what you can really do with our language and with our tool. Diving a little bit into the language, which is very commonly a question that we ask. Codel is, by syntax, based on C. I still believe that most programmers in the world know C. So that means that if you are one of them, you will very likely be able to read Codel. So you will be very likely to read implementation of a processor written in Codel. Also, learning to use it is not difficult at all as well, because it just resembles the language that you know very well. The good thing is that we with Codel can really focus on relatively narrow part of the design world. So we only focus on processors, which is different from HDLs, which need to stay very generic. So what we can give to you is this warm, fuzzy feeling that you're actually using a tool which was designed for the specific purpose that you want to do, which is designing a processor. That means that we can give you high-level constructs, which with very low effort will basically, for free, implement standard blocks from a processor that you would use with any processor implementation. So on this slide, you can actually see a register file implemented in Codel, and if you use this implementation in Codership Studio and hit Generate RTL, you will get your system Verilog implementation on the right. If you see Codel, basically it is just a bunch of parameters that you have to define. So you have to decide how many registers you want, what is their bit width, what is the reset value, bunch of things, and you will get the implementation for free. You don't have to use these built-in functions, but they basically make especially the prototyping of the processor much faster and easier. The other thing is that once you generate the RTL, you might want to have a look what the generated RTL looks like. So the good news for you is that it is human readable. We do preserve all the names that you decide to use Codel into the generated HDL. So if you then do any debugging, or if you want to just have a look what the HDL looks like, it is pretty easy to understand what does it implement. And also, a feature that I didn't show in this slide because the snippet would become really long is that we can inline the HDL code with comments which would tell you which line of Codel was there to trigger the generation of this part of the HDL. So this, automatic translation shouldn't be any problem, because if you are comfortable in HDL and you want to kind of backtrack what did you do in Codel that your HDL looks like it does, it is pretty easy. Very important aspect that we can provide is we give you a good head start. So you don't have to design your processor from scratch. If you want to, you're very welcome, you can. But all the processors that I talked about in, I think it was the second slide, that we do license as standard IP, we have designed in Codel, which gives you the option to get Studio tool and processor from us and use it as a start for your differentiated design. So you don't have to worry with the baseline RISC-V processor. That can come from us, and you only have to focus on your customization of it. And I'm not talking about examples. Of course, we had lots of examples how you do design different things in Codel, but these are production-ready processors that we sell to many customers also as a standard IP. And that actually brings me to the last slide, so I will try to summarize. What I believe RISC-V brought is a promise of openness. It is a definition of an instruction set that is not owned by anyone. You can go, you can use it, you can base your products on this instruction set, and you will not have to pay anyone money for it. The problem is that it can be quite difficult to do so, and this is why I believe that Codasip makes the promise reality, because we have the tools to do exactly that. So if you license our processor and Studio, you will be really able to create your differentiated design. You will own the resulting IP, and of course, we will not charge you any extra money for architectural licenses for doing so. So thank you. I really encourage you to come to any of our booths, because we actually have two of them. We're here at RISC-V stand, so here's always 1 or 2 people here. If you want, in Hall 2, we have much bigger stand. We have a bunch of demos running there, so go there, check the demos. In the afternoon, we will have wine and beer, so stop by for that. And I also think that you should stop by here tomorrow for Rupert's talk about the end of Moore's Law. Thank you.